Thank you. I'd like to thank SAGES and the panel for the opportunity to discuss our findings. Disclosures, no disclosures from myself with relation. We do have intramural and extramural funding. This study involves multiple centers and is multidisciplinary, and so we have folks from Arkansas, Indiana University, where I'm from, and Boston Beth Israel Deaconess Medical Center. So the background. Colorectal cancer, it's certainly one of the most common cancers that we encounter in the United States. ESD has been emerging as a minimally invasive approach to allow unblocked resection of large non-infiltrating mucosal-based lesions and lower recurrence rate compared to EMR and long-term studies. There are certainly challenges to ESD. However, number one, it's quite technically demanding, more so than foregut ESD. Second, advanced training is necessary. It requires complex cognitive and psychomotor skills. It takes longer than EMR and potentially higher rates of complications for the procedure as well. One of the big issues, there's no standard training in the United States, and given the volumes at certain centers, classical apprenticeship model may not be practical. So that led to this project and this study. Basically, our broad, large objective is to design, develop, and validate a high-fidelity, force feedback-enabled virtual reality ESD simulator. This talk, however, just talks about the very first point and the first task, which is to perform a task and cognitive analysis of the ESD procedure and to develop objective and quantitative metrics therein. And so a hierarchical task analysis is basically a method that details the steps of a procedure from the beginning to the end. And this is to identify the crucial task in each phase of the procedure and then to create metrics. Basically, why we do this is because the folks that make virtual reality simulators are engineers and they're biomedical, mechanical folks. They're not clinicians. And so this task analysis will then be translated and programmed into the virtual reality simulation platform. And so the process for this is that we performed a thorough literature review of the colorectal ESD procedures, and we consulted with expert ESD endoscopists in Asia and the United States, and consensus was derived by a modified Delphi process. So we identified 6 major phases of the colorectal ESD procedure. Number 1 is the preparation phase. This is prior to the procedure. Second is the marking phase around the colorectal ESD lesion. Next is the injection phase to give yourself a protective cushion in the submucosal space, and followed by the circumferential cutting phase, the submucosal dissection phase, and the evaluation phase at the end and throughout the procedure, looking for any bleeding, perforations, complications. And so for each one of those 6 phases, we created a hierarchical task tree to basically derive each of the steps and potential decisions to be done for each phase. So for instance, this is the preparation phase. First you prepare and choose the tools that you need, select the correct scope based on where in the colon it may be. That may be an upper endoscope, a pediatric colonoscope, and then anesthesia type, and then trying to put the lesion in an anti-gravity position. Due to the time restraints of this talk, I don't have the capability to go through all of the phases, but I'm just going to show you that for each one of those 6 steps, we have a hierarchical task tree for this procedure. And then also we have individual task trees for managing complications in perforation management and also bleeding management. And so the next step was to derive performance metrics for this. And so we developed grading metrics based on a Likert scale, 0 being basically the worst possible thing that you could do, and oftentimes that would end the simulation. So for instance, if you have an enormous bleeding area that you don't manage and you let it go till the end, or there's a number of different examples. And 5 is the best possible optimal action for that phase. And future studies will be used both in the developed simulator and also in real life to test the validity of this grading scale, and it's possible it may be modified in the future. To give you an example of the grading metrics, these are metrics for the marking phase. The objective is not to look at every detail here, but just to show that for every phase, we have grading metrics. And then the next step of this study was we looked at 16 videos of colorectal ESD performed by 4 different endoscopists, and we did a time and performance analysis. So basically, according to the hierarchical task trees that we developed, we specified timing guidelines for the folks that looked at each of the videos so that we could quantify what's the average time for each step, what's the variability of time in each step. And then we also applied the scoring gradation to those videos as well. We did hypothesize that there may be an inverse relationship between the duration of the task and the performance score. So, i.e., if someone does very well and they have a high performance score, perhaps the task duration will be less. These are some examples of the time for each of the phases, and on the right are the detailed measures for each one of the phases as well. As one may expect, for instance, in the submucosal dissection phase, actually cutting the submucosal layer is the longest subtask. So this is my final slide. Basically, what we showed here, now granted, there are some major caveats here because each of the 4 endoscopists were expert endoscopists, but there was a significant negative correlation between the timing of certain phases and the scores of the total score and the essential dissection phase. That's basically the ESD phase, which takes up the most time and has the most possible score. And you can see those there. I will say that I think the correlation between time and score will have much more value once we start testing the simulator with novices and with experts and compare there. And then just one final plug, we have started to build the hardware and software for this. And if anybody's interested, the Learning Center, there's a setup if you want to try. Thank you.